Okay, I think I'm live now. So, hello everyone. I hope you all are doing well. This side Priya Bhatia. And in this video, I think you already have seen from the thumbnail that we will talk about the recursion concept, which is one of the most important concept whenever we are talking about solving any coding question, right? तो आज के वीडियो में we will talk about in a very great detail that how we can solve the questions, coding based questions in the interviews, in the real time practical examples via the concept of a recursion in Python. So this is a video for, I would say, extension of the playlist that we are continuing, Python programming playlist. First of all, I'm really sorry to get join very late because of the internet issue. I won't be able to connect at correct 8 p.m. IST. So I have delayed it by 30 minutes intentionally. And the second thing is, just please give me the confirmation that whether I am properly visible, clearly audible or not, so that I can start further my session. So I will be waiting few minutes so that everyone will join, those who want to really want to join, and then maybe I'll start the session. uh, नमस्ते मैम, काफी वेट था आपकी लाइव क्लास का. ओके, मेरे को भी वेट था लाइव क्लास लेने का, बट इट्स जस्ट समटाइम्स थिंग्स विल नॉट वर्क आउट एट द करेक्ट टाइम. इट्स ओके, थिंग्स हैपन, है ना. uh, सब कुछ विजिबली दिख रहा है, क्लियरली सुनाई दे रहा है सबको. Okay, perfect. I think I got the confirmation that yes, it is audible also. तो एक काम करते हैं, सबसे पहले स्क्रीन शेयर कर लेते हैं so that in the meanwhile people are also joining. कुछ लोग हो सकता है कि वेट करके भी चले गए हों, might be the case, but it's okay. They can watch the recording as well. But आप लोगों ने पेशेंस दिखाया, उसके लिए बहुत बहुत शुक्रिया, है ना. Is my screen is visible? दिख रहा है, right? I can see on the other screen, दिख रहा है. Okay, perfect. So what is the objective of today's session? The simple objective is that in today's session we want to talk about the concept of recursion in Python. Python is the way to implement the recursion concept, but recursion is something that we have to expertise on after this session. तो स्पेसिफिक फोकस जो रहने वाला है आज के सेशन का, वो रिकर्जन पे रहने वाला है. एंड वी विल ट्राई टू एक्सप्लोर द पॉसिबिलिटी ऑफ दिस सेशन, दैट रिकर्जन क्या होता है, एट व्हाट पॉइंट ऑफ टाइम वी शुड गो फॉर रिकर्जन अप्रोच, राइट. आई वुड से दैट दिस इज द हार्ट ऑफ DSA, data structure and algorithms. I hope you must have seen my playlist of DSA, right, where I have specifically talked about this topic. But I thought that I'll take this topic in the live with respect to the Python playlist also, because as I told you, this is one of the very important topic that we have as per the concepts of Python. Okay, so let's try to start with the very first concept, that what is the meaning of recursion. What is the meaning of recursion? So simple meaning is that at any point of time, whenever the function is calling itself, whenever the function is calling itself in the method definition. So whenever we are defining the method, or whenever we're defining a function, now I hope you must have seen my previous video where I have defined already that how we can define a function in Python. Have you checked that? So I will show you also the video which I'm talking about here. So let me just go to the playlist, and in that playlist, if I'll go towards the Python programming, the ultimate playlist, here if you will see, the last session was on the mastering functions in Python. Can you check this? So this is the important video and the important prerequisite of today's session. So you should know that how we can define a function. Okay. So whenever we are defining a function, if let's say a function is calling itself inside that method definition, that is something which you call as a recursion. Now you will say that okay, this is about the definition, ठीक है, पर logically एक example के through समझते हैं कि recursion क्या होता है. With the help of that, I think you will be able to get a better picture of recursion concept. The simple example is, I hope everyone is aware about the fact that how we can do a factorial of any given number. Factorial of any given number. सबको पता है फैक्टोरियल कैसे करते हैं? Is everyone aware about the fact? Let's say if I'll ask from you, what is the factorial of 5? What will you answer? You will say the factorial of 5 will be 5 into 4 into 3 into 2 into 1. So the answer will come out to be 120. Can I say everyone? The factorial of a given number is 120. So this is how basically we will be able to get the result. Now, the question is that in terms of recursion, in terms of recursion, how we can solve this problem? Okay? Do you know that what is 0 factorial and what is 1 factorial? Do you know the answer of this? Anyone who can tell me? What is 0 factorial and what is 1 factorial? The answer will be equals to, I hope everyone knows, 0 factorial is equals to 1 and 1 factorial is also equals to 1. Always remember that whenever you are trying to write a recursive code, you should know two things. One thing is the base case condition. Base case condition. The condition where your code will get stopped. For example, in this case, when you're talking about a factorial case, what I'm saying is that at any point of time when the value of n is less than equal to 1, return the answer as 1. Return the answer as 1. Yes or no? Because we know that the factorial of 0 is also 1 and the factorial of 1 is also 1. But if let's say that is not the case, if let's say that is not the case, that's where the second important point will come into picture, which is recursive function call that we will do. We will make a recursive function call. What is the meaning of that? Let's try to understand. Okay. For the 5 factorial, can I say 5 factorial is nothing but 5 into 4 factorial? Can I say everyone? 5 factorial is 5 into 4 factorial. 4 factorial is 4 into 3 factorial. 3 is nothing but 3 into 2 factorial and so on. So basically what I'm doing here, let's say I want to calculate the value of a fact of n. I'm saying that if let's say the value of n is less than equal to 1, do one thing, return the answer as 1. Otherwise, what we have to do, we need to return the answer as n into fact of n minus 1. Yes or no? Fact of n minus 1. This is the simple recursive code which you can say. Now, why I'm saying this is a recursive code? Because you have to understand this is the method name. This is the function name. Yes or no? This is the function name that we have. And we are calling the same function name inside the definition. This is called as recursive call. And always remember, in a recursion, there will be a recursive call inside the method definition. That's why this term is called as recursion. Repeating its same thing, but with a different set of parameters. This block is something which I will call as a base case condition. Base case condition. So in every recursive code, in every scenario, you will have two components. First component is the base case condition. Second component is the recursive call. Always remember. So how will it work? Let's say you want to calculate what is the value of fact of 5. So where this call will go? The value of n is bigger than 1. So it will go in the else part and will return the answer as 5 into fact of 5 minus 1, which is 4. Can I say yes or no? Similarly, the value of n is bigger than 1 again. So the answer will return it as 4 into fact of 3. Fact of 3 will return the answer as 3 into fact of 2. Fact of 2 will return the answer as 2 into fact of 1. 2 into fact of 1. Finally, when you will reach the point where the value of n is 1, you will return the answer as 1. So 2 into 1 is 2. Now you will go back. Now, this is the important point where you have to understand. You can ask me one important question here. That Priya, you are calling a function again and again, and you are moving until your base condition is meeting. But how my function will get to know that after fact 1, fact 2 will be called? And that's where I will say that there is something called as a stack-based data structure which will come into picture. Now, how many of you will be aware about the fact of a stack? How stack will work? Stack says that it's a LIFO kind of a implementation. Last in, first out. It means that every function call from the very start, you are trying to store in the stack. So what will happen? Fact of 5 will be stored, followed by fact of 4 will be stored, followed by fact of 3 will be stored, followed by you have called fact of 2 will be stored, followed by fact of 1 will be stored. Now stack says that I will implement in the form of a last in, first out. So what will happen? Whichsoever be the last fact of 1, it will come out and it will return the answer as 1. After that, automatically, fact of 2 will return the answer as 2. Now function call will go back to fact of 3. Fact of 3 will return the answer as 6 because 3 into 2 is 6. So fact of 3 will return the answer as 6. Now fact of 4, function call will go back to fact of 4. It will return the answer as 6 into 4, 24. Yes or no? So 24 will be returned. After that, 24 into 5, 120. It will be returned by factor of 5. So finally, 120 will be returned. So what is happening? Once you will be able to execute your complete code, you will be able to get the final answer as 120 and your stack will be empty. So when you're starting your code, you are filling all the function call storage in the stack-based data structure. Once you will be completed with the execution of the code, what you are trying to do? You're trying to store all those function calls in the stack, and after the execution of the code, your stack will become empty. You are not having any sort of function call now available in the stack. And that's what indicates that now your stack is empty, you're not having further function calls. It means your code is successfully executed, and now you will be able to get the answer as 120. Is that clear to everyone? Can I get some confirmation? Something like some symbol you can give me so that I will be able to understand that, okay, now you're getting my point. If you have any issue, anything you want to ask until so far, whatever I have discussed with the example of a factorial, please do ask from me. Otherwise, whatever thing I have just talked about, I will show you the demonstration of the same. With the factorial example, I'll show you the exact part. Clear? Okay, so I got the confirmation. Can everyone give me the confirmation? Whosoever is watching me live, please give me the confirmation. Shall we move ahead to execute the code? Our very first code, very simple code of a recursion, whatever we have discussed, that is how we will be able to get the factorial of a given number. So now whatever codes I will do today, I will try to apply the recursion here. Okay? I will not do anything without recursion because today's focus is only on the recursion part. So let's try to be focused on that part. It's not like that we cannot do the code without recursion. We can do, but at the end of the session, I will make sure that I'll try to talk about that at what point of time you should go with a recursive code and at what point of time you should avoid that. So please make sure that you will be with me until the very end of the session. Then only you will be able to get a proper gist of the today's session. Okay? So let's move ahead. Let's say you need to define a fact of n. Okay? And here you will define the base case condition. That's what I have said. The first thing in the recursion is to think about what is the base case condition. What is the base case condition? So base case condition will be if the value of n is less than equals to 1, what we have to do? We need to return the answer as 1. Can I say? Because my 0 factorial is also 1 and my 1 factorial is also 1. Right or wrong? Second important thing that we have to make sure is the recursive function calls, because we are doing the recursion here. In else case, what we will do, what we are saying, we are trying to directly return the answer as return n into fact of n minus 1. That's it. Let's write the driver code here where we are calling this function. Let's say n is equals to 5 and let's say I'll say fact of n print fact of n, and that's where we have made the function definition. Function definition. Is it fine? This is what we have discussed just now. Is this clear? Okay, let's run this. So what we're getting the answer as 120. If you will change this number to maybe 12, accordingly your answer will get changed. So you're getting some bigger value and you can just check it out. This value is correct. Okay? So this is something that is a very simple code to just to understand what is the meaning of a recursion. So here, if you will observe, this is the method name. And because we are calling the same method inside this function definition, that's why this is called as a recursive code. So whatsoever code I will write, so all the codes available in this file contains recursion only. Okay? This is what you have to make sure. Shall we move ahead now to the next interesting thing? I hope this part is clear to everyone. Very important concept, heart and soul of DSA, I always say. And there are so many people who request me to take this recursion concept live rather than doing the recorded session. That's why only I have conducted it as a live session so that you can ask me questions side by side. Okay. Okay. Now, this is fine. That's where we will be able to get the idea. And we have understood one interesting point here. There is one interesting point to note here, that every recursive code requires what? Requires extra stack space. Why? To store the function calls. Can I say, everyone? To store the function calls. Yes or no? To store the function calls. Very, very important. Now, here let's talk about the complexity part. Now, for this complexity part, see, every recursion code, whatsoever recursive code we will today see, every recursion code, we will be having some recursive solution. Or you can say we'll be having some recurrence relation. Now, how many of you knows that how we will be able to solve the recurrence relations? We will be having three methods to solve any recurrence relation. One is the substitution method. Another one is the Master's theorem. Master's theorem. And another one is something that we have is a recursive tree approach. How many of you are aware about these things? I have taken a separate session in a great detail on my channel. If there is someone who is saying that I'm not aware about what things you are saying, after the session, I would highly recommend that person to go in this DSA using Python playlist and check it out. This particular session, this is a very long session, the art of solving recurrence relation techniques for success. A very bigger session, you can see 1 hour 48 minutes 52 seconds. But once you will be able to completely watch this particular session, I am 100% sure that you will be able to gain the understanding that how we can solve this recurrence relation via the three techniques that I am talking about. So I will take a very brief part of the same. I will not go in a lot more depth because I have already taken the session for the same. But I'll show you that how basically we can solve any time complexity based question in the recursion part. For example, here if you will observe, we have two components just now I have talked about. One is the base case condition. You only tell me in this base case condition, what is the complexity? Are we using any extra looping or are we using anything extra bigger here? No, right? It's just simply return statement. So the complexity will be C. Factor of n is nothing but T of n, right? So T of n is the time complexity of this particular complete code of factorial, where base cases require a constant time. Now let's jump to the second important component, which is the recursive call. Here we're just doing multiplication, right? With a recursion, T of n minus 1 plus again a constant task, because multiplication is nothing but is a constant task. Whenever you're multiplying a value of 5, 4, 3, 2, 1 with any number, it's a constant thing, right? Multiplication, addition, subtraction is a constant task. So all in all, if you will join these terms, you will be able to get one recurrence relation, which is T of n, which is equals to T of n minus 1 plus C. And if you will solve this recurrence relation by any of these methods, you will be able to get the complexity as T of O big O of n. Now I'm not solving it step by step. As I told you, just refer that video which I have just now talked about. If you want, I can mention the video link in the description of this video also. That is the prerequisite with the help of which you will be able to understand how we can solve this recurrence relation to get the answer as big O of n. But as of now, just have a bleep faith on me that this is something is a linear time complexity task considering the above recurrence relation. So far so good. But because we are using an extra stack space also, that's why our space complexity our space complexity of this code will also be bigger of n. Why is that so? Because here, if you will observe, when the value of n is 5, you are using 5 level stack space 1, 2, 3, 4, 5. When the value of n is 10, obviously you will use 10 level stack space. So it means that your stack space or the space complexity will also be bigger of n. What is the meaning of a space complexity? The extra space which is required to execute our code. And in this case, it is bigger of n. So far, so good. Yes or no? Okay. So someone is asking, ma'am, why does not n into t of n minus 1? So many people are confused in this point. I have seen that so many textbooks are also mentioned that term as wrongly. You might seen that some people are mentioning in their videos also n into t of n minus 1. See, why I'm saying it should not be n into t of n minus 1. The simple reason is that, see, here we are doing a multiplication with a number. Like what you are doing, you are saying 5 into, this is a repetitive task, then 4 into, this is a repetitive task, then 3 into, this is a repetitive task. But this multiplication, which is 5 into 4 into 3 into 2 into 1, this multiplication, or let's say there will be addition also, 5 plus 4 plus 3 plus 2 plus 1, or there's a subtraction also. All these mathematical operations is a constant task. That's why it will be t of n minus 1 plus c, not n into t of n minus 1. I hope it is clear what I'm trying to convey here. These mathematical operations are a constant task. This is not something which is requiring a lot of time to consume. You are just multiplying it with the value of n. That's it. So that's why. But why does t of n minus 1? Because it's a repetitive task. We're repeating this task. So t is coming from the recursion part. So wherever you're repeating the value, t will come again. Is this part is clear to everyone? Shall we move ahead? Shall we move ahead? Yes or no? Okay. Now the next interesting question is Fibonacci series. I hope everyone knows what is Fibonacci series. Everyone knows that. What is Fibonacci series? It's a mathematical series where the current number is the addition of previous two consecutive numbers. So here, let's say we will be having 1D array. We will be having 1D array. And in that 1D array, let's say we will be having the numbers like 0, 1, 2, 3, 4. This is the index number. When the value of n is 0, I am saying the answer will be 0. When the value of n is 1, I am saying the answer will be 1. But when the value of n is 2, the answer will be the addition of previous two numbers. It is 1. At 3, it will be 2. At 4, it will be 3. At 5, it will be 5. At 6, it will be 8. At 7, it will be 13. So what I'm doing here is, I'm doing one simple task. If you will be able to observe this. Fib of n. I'm saying when the value of n is less than equal to 1, my answer is n itself. Why I'm saying so? Because here if you will observe, when the value is 0, answer is 0. When the value is 1, answer is 1. But at any point of time when the value of n is bigger than 1, so here if you will observe, my first task is done. First task was base case condition. And that is done now. I have mentioned about the base case condition here. What is the second task? Second task was about mentioning the recursive function call. Where my task is repeating recursive function call. Recursive function call, where my task is repeating. So here in else case, what we can return? We can return fib of n minus 1 plus fib of n minus 2. Because what you are trying to do, you are trying to at each and every time adding the previous two values. For example, If let's say you are saying that I want to get the value of fib of 3, so what you will say, because the value of n is bigger than 1, you will say what is the value of fib of 2 plus what is the value of fib of 1. Again 2 is bigger, so you will again make it fib of 1 plus fib of 0. Now you know the answer. Fib of 1 is 1, fib of 0 is 0, 0 plus 1 is 1, then 1 plus this also 1, 1 plus 1 is 2. So fib of 3 will return you the answer as 2. Here if you will observe, that is what our answer is. Is this part is clear to everyone? Yes or no? Yes or no? Everyone? Clarity is there? Okay. So here if you will observe, there are few logistics I am seeing in the chat window. I'll take it up at the end of the session so that no one will feel distracted from the session. Okay. I'm intentionally not picking up. I'm reading everything, but I'm not picking up because I want everyone to focus on the session itself. Okay. So here, this is how basically the things will go. Now, if I'll ask you, what is the recurrence relation of the same? So here, if you will see, in the base case condition, again, it's a constant task. Let's say fib of n is a t of n time complexity task. So what is the else part recursive relation? Who will tell me? What is the else part recursive relation? It will be, because you are calling a recursion again with a t of n, so it will be t of n minus 1 plus t of n minus 2. Yes or no? So basically, we will be able to get a recurrence relation which is equals to t of n, which is equals to t of n minus 1 plus t of n minus 2 plus c. And this recurrence relation you can solve via only the recursive tree approach. In the video explanation, I have clearly said that at any point of time, whenever you will be having more than one recursive tree, always we will always go with the recursive tree approach. And when you solve this problem, you will be able to get the complexity as 2 ki power n. And again, if you will refer the video of complexity classes, this video, you will be able to observe that this is an exponential time complexity. This is an exponential time complexity, which is very, very high. Very, very high. So, this is the major issue in recursion, or you can say this is the drawback of using recursion. What is the drawback? I'll explain you in a more detail. We cannot use master's method. No, for this particular case, where you will be having more than two recursive terms, t of n minus 1 plus t of n by 2, n minus 2, you cannot use master's theorem or substitution method. You have to use the recursive tree approach. So Aman is saying, will you please give the idea how to solve this? I can give you, but it will take actually a lot of time. Let me give you a brief overview. So what is happening is you're trying to split your values into t of n minus 1 and n minus 2. And the cost required, means the splitting required, is C. It is C. N is splitting into n minus 1 and n minus 2, means you're calling f of n minus 1 plus f of n minus 2. The cost function requirement is C. How it is getting up? You can see the recurrence relation. C is the extra thing which is there. Okay? Again, what will happen? When you will split it into two parts, it will be n minus 2, n minus 3. Again, C is the thing which is there. N minus 3, n minus 4. Again, C is there. So for the second level of this tree, you will be able to have 2C. Some people usually get confused between what is this C and C, what I am writing here. You can clearly see here that constant time is something which is a base case condition, plus this addition operation. We are doing addition also, right? So whenever we are splitting up, we are doing an addition operation. Just now, a few minutes back, I have told you the addition operation, multiplication operation, right? Division operation is a constant task. So everything I am writing it as a C. So when you're splitting the data into two components, n minus 1 and n minus 2, this is the cost which is required. Similarly, here also, when you're splitting, this is the course which is required. This is the course which is required. Similarly, when you split into further parts, 2, 2, 2, 2. So what will happen for this C, for this C, for this C, for this C? So you will observe in the third level, it is 4C. So what is happening is 2 ki power 0C, 2 ki power 1C, 2 ki power 2C, and so on. So you will observe one pattern is coming up. What is that pattern? You're observing on the left side, you are doing a subtraction by 1, n minus k, which is equals to, until you reach to the last level where you will be left with a simple base case condition where your value of n is equals to 1, right? What you want is final answer to be 1. On the right side, this is on the left side, which you are doing. On the right side, what you are doing is, you are doing n minus 2 times subtraction. So basically what is happening is you're trying to check it out which level is bigger one. And here you will see the value of k equals to n plus 1 is the bigger level. So why I'm trying to calculate this particular thing, try to understand. See, until what point of time I will keep on moving downward, 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 until I reach to a condition where I will be left with a value of n as 1. Means until I will reach to a condition which is a base case condition in my recursive code. That's why I have make it as a 1. So my levels, this k indicates the number of levels in this recursive tree. And you have observed that in every level, we are adding, our value of 2 ki power will keep on increasing. So what is happening is, taking C as an outside, 2 ki power 0, 2 ki power 1, 2 ki power 2, when we are at a second level. When we are at a third level, it will be 2 ki power 3. Until what? Until we reach to a 2 ki power k level. This is something that we call as in mathematics GP series. GP series, where if you will observe, common ratio is same. What is the common ratio? It is 2. Can you see? 2 ki power 1 by 2 ki power 0. Common ratio is 2. 2 ki power 2 by 2 ki power 1. Common ratio is 2. It's a GP series. Now, if there is someone who is not aware about these things, it's just basic math. You can just go and check it out. You will be able to revise that. Okay? Now, the sum of GP series is something when the value of r is bigger than 1, if I am not wrong, is a into r ki power n minus 1 divided by r minus 1. This is the simple formula to get the sum of a GP series. So what is A? A is the first element that we have. So the value of A is 1. What is R? R is 2. What is N? N is the number of elements that we have, which is n plus 1. So almost equals to n itself. So if you will solve this, you will be able to get 2 into, A value is 1. 1 into 2 ki power n minus 1 divided by 2 minus 1 is 1. So in terms of big O, your value will come out to be big O of 2 ki power n. This is how basically step by step you will be able to solve this problem. And I have clearly explained not only this single problem, but multiple problems of the similar variety in this video of 1.5 hours, the art of solving recurrence relation. So if you want to see the variations of multiple problems of the same, so that you will be able to get a proper understanding of how we can solve it, please do check it out. But as of now, I have shown you that this Fibonacci series problem is taking something called as an exponential time complexity. I have given you the proof as well. Now I hope everyone will agree with me. It's a exponential time complexity task. Is this part is clear to everyone? Now the question is, it's a very bigger time complexity. And I have said you this is the major drawback of recursion. Whenever your recursive code is giving you exponential time complexity, please try to avoid using recursion there. That's where DP, dynamic programming, came into picture. Okay? I have talked about DP in a separate live sessions. Please go and check it out. The same thing I'm talking about there. What is DP? How basically it will work? I'm not going into that much depth. But today I just want to show you what is the major issue with recursion. See what is happening in this particular question of Fibonacci series. Let's say if I want to calculate the value of fib of 5. What is happening is I'm trying to split into fib of 4 and fib of 3. Similarly, fib of 4 I'm trying to split into fib of 3 and fib of 2. Fib of 3, again I am trying to split into fib of 2 and fib of 1. Fib of 2, again I am trying to split into fib of 1 and fib of 0. What is the issue? Again, this will get split into fib of 1 and fib of 0. Again, this will get split into fib of 2 and fib of 1. Right? Fib of 1 and fib of 0. So what is the issue is happening? The issue is that we are trying to recompute the same function call. Fib of 2 we have computed 3 times, or our recursive code have computed 3 number of times. Fib of 3, again, if you will observe, 2 number of times. And here I have taken the value of n as very small. But in worst case, when the value of n is very, very big, what is the major issue in this code? There is a recomputation of same function calls are there. So there is a recomputation of same function calls. And that's the major issue in this recursive code, which leads to an exponential time complexity. Is this problem is clear to everyone? And this problem is famous by the name of overlapping subproblem. Means there is an overlapping of the subproblems and we are trying to do the recomputation here. And that's the major drawback of recursive code. So whenever, at any point of time, please mark my words what I'm saying here, at any point of time in any of the recursive code, you will feel this issue is coming up, this overlapping subproblem. It means that recursion is not an optimized approach. It means that we have to think over the dynamic programming approach to solve the same. This is a very important point to note in this session. I hope it is clear to everyone. Any doubt until so far? Please do ask from me. Anyone who is having any doubt, is this clear? Can I get some confirmation from everyone, whosoever is watching me live? So it's a very, very important concept in the, in this particular Python programming playlist, which we have started. Very important concept to solve the coding questions in an interviews. Basically, this concept is very crucial whenever you are trying to understand the applications of divide and conquer. So now if today you will go back to the Python DSA using my Python playlist, you will see that I have talked about divide and conquer concept and the applications of that, like merge sort, right? Like quick sort. I have already have shared these videos. So you will observe that this today's concept is important to understand these topics. Similarly, dynamic programming, you will not able to understand if you don't know the concept of today's session. Again, the prerequisite is to understand the recursion. Specifically in both of these modules, if someone is not aware about or is not having a good expertise over the concept of recursion, he or she will not able to understand the concepts of divide and conquer and DP. Yes, DP is the next step of recursion, you can say. So I think I got the confirmation that so far so good. Let's jump to the last question of today's session, which is about sum of given numbers, which will help you to get a better understanding of a complete thing that we have discussed in today's session. Let's say if I'll provide you a number which is equals to 1, 2, 3, 4, 5. Before jumping to this question, let me try to first of all do the implementation of this particular part just now, which we have discussed, Fibonacci series. So what we have discussed here, so the question is to get a Fibonacci number in a given series. So how basically we can get that? Let's try to see. Def Fibonacci, and let's say we will be having a number. So the very first step is the base case condition. So what is the base case condition? The base case condition will be the value of n is less than equals to 1. What we want is we can return the n. Otherwise, the second thing is the recursive function call. Recursive function call. In that case, in else part, what we can do? We can simply return Fibonacci of n minus 1 plus Fibonacci of n minus 2. Done? Simple? Okay, driver code I haven't written down. So let me do one thing here. Here itself, let me write the driver code. where let's define the number as 5. So what I want to print is what is the value of Fibonacci of that number which we are passing. Okay? Fibonacci of that number. So this is the method definition. Method definition. Done. Let's run this. So we are getting a very correct answer. It is equals to 5. Correct? This is what we have understood in our session also. Now the next problem is that we want to get the sum of the digits. Okay? For example, if let's say the number is equals to 1, 2, 3, 4. So what is the output I am expecting? It should be equals to the summation of 1 plus 2 plus 3 plus 4, which will come out to be 4 plus 3 is 7, 7 plus 2 is 9, 9 plus 1 is 10. Right? So this is what I want. Anyone who can let me know how can we solve this problem? So basically what we are looking for is, we are looking for the addition of the digits that we have in a given number. For example, if we will be having 1, 2, 3, 4, so we are looking for the addition of all these numbers. So the answer will come out to be 10. How can we solve this? Anyone who can give me a logic behind this? Let's see who will be able to give me the correct idea. First of all, think about what can be the base case condition of this approach. First question is, which you have to ask. So in every recursive code, just ask one question. What can be the base case condition for this problem? So the base case condition will be when the value of n is less than 10. Let's say you will be having the value 9, only 2 is there, only 3 is there. At that point of time, obviously, you will return directly n, right? Because that is only the sum. Whenever your value of n is less than 10, that itself is the sum, right? Let's say if the number is 9 or 8 or 7, that itself is the answer. Else case is very interesting to understand. What I'm saying is, in else case, what we have to do, first of all, we have to figure out how we will be able to get the digit. It's very simple. Just use the modulus operator. Modulus operator will give me the remainder, right? Remainder of a given number. And then I have to avoid that number. So what I will do, if let's say my function name is sum of a given number n. So what I will do, I will say sum of n by 10. Very simple. See what we are doing here. So let's say we will be having 1, 2, 3, 4. This number is bigger than 10. So it will return, what is the n modulus 10? What is 1, 2, 3, 4 modulus 10? Plus sum of 1, 2, 3, 4 by 10 is 1, 2, 3. The remainder will be 4. 4 plus sum of 1, 2, 3. Now same thing will happen here. This will return me the answer as 3 plus sum of 1, 2. Again 2 plus sum of 1. Now it is a number which is less than 10. So it will return the answer as 1. So ultimately what we will be able to get, 1 plus 2 plus 3 plus 4. We will be able to get the answer as 10. Very simple. Very simple, right? So the simple funda is that we have to think how we will be able to get the unique digits. Firstly, we will be able to get the unique digits. How we will be able to get rid of that particular digit which we have already included. Very simple. So what we have done here is, just focus here. Simple point is, we have said def sum of digits is the function name, let's say, containing n. We are saying if the value of n is less than 10, do one thing, return that number itself, because that is the only sum. Otherwise, what you have to do, n modulus 10 plus, this is the recursive code, sum of digits, n divided by 10. Done. So two things are there. One is the base case condition. One is the base case condition, and another one is the recursive function call. And finally, what we can do is, we can write a driver code where our value of n is equals to, let's say 1, 2, 3, 4. We will call our function print sum of digits, and here we can mention num n. If you will run this, okay, One thing we have done wrong, it should be return. Uh, okay. Okay, it is giving me this number. Is this correct? 1, 2, 3, 4, 5. Let's see what it will be able to give to me. I think this is correct. 5 plus 4, 9 plus 3, 12. 12 plus 2, 14. 14 plus 1, 15. It is giving 16.5. One issue is coming up. Do you able to understand what is the issue? Anyone who can let me know? Why is that issue is coming up? Because see, there is a floating point number which is coming up because of this operator which I am using here. So in order to get the exact value like 1, 2, 3, 1, 2, and 1, I have to use double slash in Python. So let's run this now. Now I think we are getting the correct answer. Even let's see if we will be able to get that 1, 2, 3, 4. Now it is giving the correct answer because it will not take that float value, okay, while doing the division part. Is this correct now? I hope it, yeah, many people have already answered it that what's the issue in this code. Yeah, perfect. Okay. Now, this is perfectly fine. The question is that we have talked about different questions in recursion. We have seen the disadvantage of recursion also. We have talked about what is the limitation of using the recursive code. But another question which you should have in your head is that what is the advantage of using recursion? And at what point of time you should go for recursive code? What is the advantage of using recursion? So I have shown you so many problems with respect to recursion in today's session. What do you think? What is the biggest advantage you will be able to observe out of this session when we are writing a recursive code of maybe factorial, maybe Fibonacci series, maybe finding a sum of a digit of a number? What is the major advantage which you observe is there in this recursive code which is not there in iterative approach? What is the meaning of iterative approach, where we are using a loop, maybe while loop, maybe for loop? Because we have already talked about the looping part in Python in the previous sessions in the playlist. So what is the advantage of using the recursive code here? Anyone who can give me the idea? So this is the gist of a session. We have talked about what is recursion. We have talked about what is the disadvantage or the drawback of a recursion. What I'm really looking from you all is that after listening from the past 50 minutes, what thing which you have observed that while writing a recursive code, what is the advantage which you're feeling? Okay. So Ankit has said that there is no need to do the same task again and again. So it simply indicates that if you will observe, your understanding of the code is very good, your clarity of writing a code is very good. Another interesting thing which you might have observed is that whenever we're writing a code, there is a very lesser lines of code which we are writing up in order to execute anything, in order to get the output. We are not using a very big code. If you will use while loop or for loop, the code size or code length line of the codes will be very high. To get the same output, I'm using a very lesser line of code. Here I just have to focus on two things: what is the base case condition and what is the recursive function call. That's it. What are the recursive function calls? This is the interesting thing, right? So because of this only, we go for the recursive code. Now, we avoid recursion at the time of overlapping subproblem. Overlapping subproblem. Why? Because it leads to the exponential time complexity at that time. So we can optimize the code via using the dynamic programming approach. This is important to understand from this session. And I hope that whatever lines I have mentioned here, this should be clear to everyone. That at the time of overlapping subproblem, please do avoid this using recursion concepts. Otherwise, at the remaining time, it's quite easy approach. It's quite understanding. It gives a very good clarity to write and get the solution very easily. It contains a very less line of code. That's why I think the clarity of a code is also very good, right? Okay, so Shlok is asking the question that please explain loops versus recursion again. See, for every recursive code, we have an iterative approach also. For example, for solving the factorial question, we have done today via recursion, but we can do via the loops as well. So, what is the difference between a recursive approach versus iterative approach in terms of writing the code? In the recursive approach, if you will observe, and what I'm saying is for every recursive code, you have an iterative solution as well. For every recursive code, you have an iterative solution. When I'm saying iterative, it means that I am using for loop, I am using while loop to solve my problem. In recursive approach, there is no as such loop which I am using. There is two components which I am using. First is there will be a base case condition. There will be a base case condition. And second thing is a recursive function call, means calling the same function again. There will be a recursive function call with a different set of parameters. Now, whenever we will be having an iterative approach, you will observe this is the first difference. Second difference is here we will be having a lesser lines of code to solve the same problem. Here there will be a higher number of lines of code. Now you can ask from me, does that matter that we will write a code of fewer lines or a higher number of lines? Yes, definitely. Why? It brings to a clarity. If you have a very lesser line of a code, it brings a code clarity. You only tell me that you went to an organization and someone have written a very big code, and if I write that same code in a very small lines of format, which code will you prefer? You will prefer the code which is having a very lesser lines. It will be easy, it will be clear, it will provide you better clarity, right? That's the only reason. Okay. Now the next interesting thing which you will observe is in the differences part that here the stack space is required, even though the time complexity of a recursive code and the iterative approach for a question is same, but the stack space is required in the recursive code. But in the iterative approach, there is no need of extra stack space. So in terms of spacing wise, if someone will ask you which code is better, you will say that iterative approach is better. If you want to save the space, you can go for the iterative approach rather than going for a recursive approach. This is the major differences of recursive versus iterative approach for any given problem. I hope it answers your question, Shalok. Okay. DP session in next video. I have already taken the DP live sessions also. You can check it out in the playlist. I think in the very last part, you will see introduction to DP, learn to code efficient algorithm. I think I have taken the live sessions also, live DP, programming solving skills. So please check it out. Those sessions which I have already taken live, I will not repeat it again and again. You can check it out in the recorded videos. Today's session also, if let's say someone have missed the initial part, you can go and check it out in the, not this playlist, Python programming playlist. This is the next video, mastering recursion in Python. Everything is recorded now, and you will be able to check it out before coming to the next important video where we will talk about most probably the OOPS based concepts in Python. Okay. Now if you have any questions, you can ask. Otherwise, we can wrap up the session. I am already uploading all the content. Okay. For those who are not aware, that I am uploading all the content of this Python programming playlist in my GitHub repo. You can just search Priya Bhatia GitHub. On the very first connection, you will be able to get that. Your URL of mine only will be there. I believe so. So in the very first link, you will be able to get the repository of a Python Programming Ultimate playlist. I have made it public only. So all the sessions you will be able to get inside this. I will add this session also, the content inside this session, the collab file plus the live session notes in the separate folder, mastering recursion in Python. I'll create that folder and I'll upload the content of a live session, written content plus the coded content in this particular folder itself, so that everyone can have access of that. Finally able to join live. Thanks, John. Thanks, John Wick, to join me the live. Please take Manvi Tyagi ma'am in the post podcast. Definitely, I'll connect with her and I'll definitely also want to bring her as well. Uh, for those who are not aware about the fact, I have also started a separate playlist of conversation with experts, where the first episode is live now. It was a live session. For those who have missed that, you can watch in the recorded pace. Here I bring up a special guest Kaushal, who is about to complete his PhD from IIT Hyderabad. So he shared his insights regarding how we can go for PhD program and what are the aspects that we have to take care of before jumping towards this decision. Okay, what research he is doing, what is the AI research is going on currently, right? So all these things, if you are highly interested towards AI and you want to explore this kind of a career, you can go and check it out this episode also. Episode 2 is also about to come very soon. I'll share the information in my LinkedIn community post, YouTube community post, as well as please do connect with me if you have not connected with me till now in the WhatsApp channel link. So if you will see in my community post itself, I have shared the WhatsApp channel link. Okay, I think it was there. You can just check it out, scroll down, and you will be able to see the link. Okay, just check it out. I have not deleted the post of that as well. Anyhow, I will also share the now quiz questions tomorrow morning with respect to the recursion part that I have covered up today. Please make sure that you will join that quiz part also, and that will help me to get the understanding that how much you have learned from this session, right? Your DSA playlist will be sufficient for DA get exam. Yes, I think it is sufficient. It covers all the topics starting from scratch till the very advanced. So if you have covered up all those topics, I think it is more than enough. John is saying, I have some questions regarding AIML. Where can I reach you? So I think, John, you can reach out to me via my email ID. So if you will go to my LinkedIn profile, you will be seeing my about section where I have mentioned my personal email ID. You can just mail me out. I'll respond to you accordingly. Okay. I spread the channel link in my class group. Thank you so much, Ankit, for doing that. Okay. Any other doubt anyone is having apart from this? I'm just scrolling the above questions if there is something. Shobit is saying, ma'am, you are the best. Thank you so much, Shobit. After that, I think I have explained already this thing, right? Okay, so Ankit is saying, I have to give a project of weather prediction model through AI. Please provide the steps. So, Ankit, it depends on what kind of dataset, that weather dataset you have. So, if you can share with me the details completely, that this is a kind of a data, this is a column that I have in that data, how many record size you have. If you will share the information for that in my email ID, in my personal email ID, I'll check it out and then accordingly I'll share you the steps which I think you should do in order to get the predictions accurately. Okay, I hope that helps. Because just by looking into the problem statement, I can't say you that these are the steps which will be highly optimized. If I'll just have a look onto the data, then I think that would be a better way to move ahead rather than giving anything and saying anything towards the problem statement. Okay, I think this is what I have already talked about. Sometimes happens. Yeah, I think you're talking about the mistake which I have done. Yeah, that happens because I usually do in Java as well as in Python, so it happens a lot. Thank you, ma'am. Thank you so much. What is deep reinforcement learning, how it is different from deep learning. See, it's a completely different, I would say not completely, but yeah, there is a separate category of a reinforcement learning. For example, self-driving cars that you usually see. So in that, what usually happens is that model is learning from the environmental variables, right? You can take an example of a self-driving car, right, where what is happening is, on the basis of the environmental things, automatically my car is chopping up, automatically it is changing the gear, automatically it is changing the direction on the basis of the signals. So it's a completely different domain, I would say. With respect to deep learning, we are specifically in computer vision dealing with a image based data, but in reinforcement learning there are state of the art actions, rewards, penalties, everything is there. So maybe I'll discuss that in a separate talk, because it is not at all associated with the today's session which we have covered up, right? So let's not distract the audience with respect to, if I'll say more terms here itself, they will be confused what she's saying. Okay, then, thank you so much everyone for joining the live session. Thanks a lot, and I'm really sorry I have delayed it by 30 minutes, but I think it is worth waiting the session, right? So, with this, bye bye, and I'll see you all very soon. I believe that now the next live will be with another guest, which will be coming very soon. I will share the information on my channel, and kindly organize more research related podcast. Yeah, definitely. I think the PhD guy podcast was also a research related only, and in future also we will make sure that we will have more podcasts like that. I hope that you have enjoyed that. Please do share these videos, right? It really helps me to reach to more people like them, and they will also be, if the audience will be more, if you guys will be willingly to watch those sessions, then only people will also willing to come here, otherwise they will not come, right? So it also depends on you guys also. So please, I need your support also in order to reach to the wider audience. So please make sure that you will, make sure that you will, display the information in the LinkedIn post. Mainly LinkedIn is the platform, I think, where everyone related to the academia part will be there. So please make sure that you will share this info, tag me, and also these live sessions which are going on in the Python playlist. Please make sure that you will help me out to reach to more people via sharing, right? It will really means a lot to me. Thank you so much everyone, and I'll see you all very soon. I'll share the details on the community post itself. Bye bye and see ya.